I am Anil Kumar. Welcome to our series on statistics. We have many examples based on probability and expected values. These are combined with other very popular topics: mutually exclusive, independent, dependent, Venn diagrams, and so on. In case you really want to master, go through our playlist. You'll find many test problems, examination style questions in our playlist. They should help. So here is another important question, which is 120 grade 12 students are surveyed. For a student chosen at random from these 120, the probability that he has math is one third, and the probability that the student has both math and physics is one fourth. There are 20 students that do not have math or physics. So that is the situation given to us. First, you need to make a Venn diagram, and that should help you to answer the following questions. B is one of the student who joined the physics class is chosen at random. Find the probability that the student had also taken math. So we have a conditional probability question there. And C is determine whether the event joining math and physics are independent. So, see, we have a conditional probability and we also are testing for dependent or independent. Makes sense. A complete question in itself, examination style, which you normally see in IB test papers. Okay. Well, in case you want to learn directly from me, feel free to send an email on globalmathinstitute at gmail.com. We provide you with the right questions that can help answer any tough test paper, and that too in the best possible way. I hope it makes sense. Now, let's look into this particular solution. So, we are given that there are 120 total students. For the student chosen at random from these 120, the probability that he has math is one third. So, probability for math is equal to one third. So, out of 120, how many should be there for math? So the number of students who will take math will be how much? One third of 120, correct? That means total 40 students should take math. Now we have, and the probability that the student has both math and physics is one fourth. So we are also given that probability that, let me change the ink here, probability that both math and physics means intersection, right, is one fourth. So the number of students who have taken both math and physics will be how much? One fourth of 120, correct? Which means 30. Is that clear to you? Right. Now it says there are 20 students that did not take math or physics. How will you write this? This is also interesting to understand. 20 students did not take either. That means number of students who did not take means math union physics complement. Do you understand? Is 20. There is also a very good way of writing which is not asked for in the question, however, important to understand since that may be required in your test. Perfect. Now, based on this, very easy to make a Venn diagram. So, let's make a Venn diagram now. So, we'll have a circle for math, a circle for physics, and of course, they are overlapping. So, we'll write math and we'll write physics. There are, we should begin from inside. And also, whenever you make a Venn diagram, do not forget to make a box. That means the whole population we are looking into. 120 students, right? So normally we write S or U on the top. Right? Let me write S here. Make sense? Follow correct procedures so that you get marks for communication also. Now, 20 students did not do anything. Let's put them outside. 20 are outside. Correct. Now start from inside out. Math intersection P is 1/4. So 1/4 will be 30, right? So this 30 comes here. So what we have done here, we have done the number of students who took both math and physics in. Now we can go either side. Total number for math is 40. So 30 are already there. How many left? 10 left, right? So 10 plus 30 is 40. Now we also know that total is 120. So how many will be those which took only physics, right? Only physics, right? So what we should do? We should take away from 120 all the numbers which we have, which is 20 plus 10 plus 30 or 40, I could say, right? And that gives you the number which is only physics, right? So which is 120 minus 60, and that gives you 60. That's right. So we have 60. If you add and check, right? 60 plus 30 is 90, plus 10 is 100, and 20 is 120. It makes sense. So all 120 students have been accounted for. Perfect. Now we've done the first part, which is the Venn diagram. Let's look into part B. One of the students who joined the physics class is chosen at random. Find the probability that the student also taken maths. So if we say one of the students who joined the physics class, so we are choosing from the category this, correct? From this category. One of the students who joined the physics class, out of 90, you have to find the probability that the student had also taken maths, right? So basically, we are finding the probability that the student has taken math and we are selecting from physics. Get the idea? This P is for physics. Great. So that should be, as you can see, 30 out of 60, right? Because 30 is common to both physics and maths. And total is 30 plus 60, right? Which is 90. So when you simplify, you get 1 over 3. So 1 over 3 is the probability of selecting a student of math if we take it out from the physics group, right? So at least physics has been taken. So it is one third. So that is how we'll find solution for part B. Is that part clear to you? Right. You could also use the formula, right? Which is probability of P and M intersection divided by the probability of P, right? Okay. We are not using it for now. We are using the Venn diagram to answer this question. I hope it makes sense, right? Some of you can try from the other side also and get the same result. Now, part C is determine whether the event joining math and physics are independent. So, there are a couple of ways to find this answer. So, what is the probability of getting math? Figure this out. If you see from here, probability for math is how much? Probability of math is given to us as one third, right? And we see that the probability of math is also same even if we select it from the students who had taken physics. You understand? So what we notice here is that the probability for math is equal to 1 over 3, which is also equal to the probability of student selected from the physics group. And since the math probability did not change, right? So no change, correct? That means independent. Does it make sense to you? Very clearly, we are showing you that the probability of picking up a student who has taken math does not change. Whether you selected just directly from all or from the group which had taken physics. Perfect. So that is how we show in this particular case very easily without further calculations that the probability is independent. The other way could have been also you could find probability for intersection of math and physics, right? That should be equal to probability of math times probability of physics, correct? And in that case also you'll find probability of math is one third, right? And what is the probability of physics? 90 out of 120, correct? Because there are 90 students who are taking physics out of 120, correct? And when you multiply this, you do get the probability of 90 out of 20 is, see, let's cancel this, correct? Dividing by 3 gives us 3 by 4, right? One third times 3 by 4, correct? Which is how much? 3 and 3 cancel, 1/4, correct? You see, this 1/4 is intersection and it is same as given 1/4. So the probability of math times probability of physics is same as the intersection which you have seen. So that becomes the second check. However, the first check which I did that did not change is incredible. You need to understand this concept. That saves you not only time but gives you a clear idea of what you are doing. I hope that makes sense. Feel free to explore our playlist to really master this topic on statistics. Thanks for your valuable time and all the best.